Hello, my name is Michael Vriedeveld and this is my video lab report submission for Lab 4 Oscillations. The purpose of this experiment was to predict the motion of a mass oscillating on the end of a spring using VPython. After adding the necessary adjustments to the VPython code, the main result was found to be that the computational prediction was able to match the general trends of the observed oscillating mass, but the experimental observations deviated from that of the predicted model. The physical principle used in the conduction of this lab was the energy principle. The energy principle states that the combined total of the change in kinetic energy with that of the change in potential energy will equal the total change in energy of the system. The potential energy could then be broken down into the two main forces acting within the system, those forces being the gravitational force and the spring force. It was also noted that since there were no surrounding forces acting upon the system, then the total change in energy would have to equal 0. The initial conditions for this experiment were used in order to create a prediction model. It was found that the relaxed spring length was 0.127 meters and the spring stiffness was 6.87 newtons per meter. The spring stiffness was found by using the equation spring stiffness equals 4 pi squared times the mass divided by the oscillation time. The spring stiffness was then used to find the relaxed length of the spring by using the equation mass times the gravitational constant 9.8 equals the spring stiffness times the stretch length of the spring with the mass on it, 0.7 meters, minus the relaxed length. This equation can be used due to the fact that the total change in energy is equal to 0 as discussed before. This is part of the initial conditions used in the VPython code. The oscillating mass was given to be 0.402 kilograms and the initial position of the mass was found using the data taken from tracker. The initial velocity of the mass was recorded as vector 0, 0, 0 since the object started from rest. These are the rest of the initial conditions used in the VPython code. The overall strained length of the spring was found by subtracting the position of the anchor of the spring from the position of the mass. The initial energies were also calculated using their respective formulas. This is the data that was obtained within the while loop of the VPython code. Within this while loop, the gravitational force, spring force, total force, mass velocity, and mass position were updated every time the while loop ran, as to keep the data updated for the final energy graph. The changes in kinetic and both potential energies were also updated within the while loop. This is the energy plot for the computational model. This was considered to be correct due to the fact that the total change in energy, the yellow line, stays at approximately 0, which is expected to be since there should be no loss in energy to the surroundings as discussed earlier. This is the plot for the comparison between the computational prediction and the observed mass oscillation. The blue line being the predicted mass computational model and the red line being the observed mass. It can be seen that the observed mass oscillation, the red line, deviates from the computational model, the blue line. However, the overall trend of the computational model is very similar to that of the observed mass. From this resulting plot, it could be reasoned that possible reasons for this observed deviation could come from either human error, my inability of placing the tracker positions at the exact right spot, or unaccounted forces. The unaccounted force would mainly be that of drag or air resistance. It can be seen that over each oscillation, the plot of the observed mass gradually deviates more from the predicted motion. What does it mean? Question 1. For this lab, the energy principle was satisfied. This can be seen from the first computational energy plot, where the yellow line, or change in total energy, stays at approximately 0. This means that no energy was lost to the surroundings from the system, which does satisfy the energy principle. This is the second what does it mean question. For the x-coordinates, the oscillation time was found to be 1.65 seconds. For the y-coordinates, the oscillation time was found to be 1.52 seconds. The overall difference between the two oscillation times is fairly similar, but due to the fact that both the gravitational and spring force act in the y direction, the y-coordinates were used because it was believed that this would more accurately predict the correct spring stiffness. Thank you very much for watching this presentation. I hope you enjoyed it.